Ladies and gentlemen, welcome to Schneider's Golf. My name is Eric Schneider, and today we're going to be taking out the control boards and drives on the CT40. It's kind of a crazy day. We're going to start the retrofit, the Centroid CNC retrofit on the CT40. All right, so it's been a couple months since I got this CNC mill. I was hoping that I was going to be able to run it on the Mazak 640M. The more I talked with Mazak, or lack thereof, and the more that I dug into kind of what's here, what can go wrong, I decided to cut that idea off at the knees to get a new control board, which is going to be the oak. We're going to use an oak control board, which is the same one that I used for the Aero 500. I got new drives, so new X, new Y, new Z, new 4th axis drive. We're going with DMM and Delta automation for our drives, our spindle drive, and the X-axis are going to be Delta, and then the Y, the Z, and the 4th axis are going to be DMM drives, DYN4, and the 1.3 kilowatt servo motors. So for this project, I'm going to start by taking these drives out, these old drives. These are what's called SSC net. They're daisy chained together, and they are not compatible with oak, unfortunately. They would need Linux CNC to run. For the sake of time and cost, it actually was going to end up being a little bit cheaper for me, I think, in the long run, to go with the Centroid instead of Linux CNC, just because I know Centroid better, and I've had good luck with the board and the motors. There's good support for DMM motors. So these are going to be going. We're going to get rid of these old Mitsubishi drives. Now, what's kind of fun and interesting about this is that these drives are from the late 90s, and an equivalent drive is now this size, which fits in my hand. So everything has gotten smaller, computers have gotten smaller, and so have servo drives. Hopefully they'll hold some insane cool tolerances. All right, I'm a little sad that this Mazak didn't work because it's such a pretty looking control pendant. It really is. And there's a lot of guys that run these. I just love all the push buttons and stuff. This is going to look so naked when it's done. The only thing that's going to be left is the contactor panel, some of these fuses up here, and then all of this down here will be gone. We're not going to use the drives. We're not going to use this Mazak board. We're not using this Mazak board, and we're not using this. We'll still use this power supply, but this thing here will be gone. So this is going to look really, really bare by the time we're done pulling all these out. Let's get these drives out, and we'll start installing the new DYN4 CNC drives. There's no turning back. This is a once it's done, you can never go back. Goodbye. Which is a little scary because this is not a small undertaking. But we are up for the challenge. Let's go. That's weird. She's all cut. She's not going back in. All right, I've unhooked all of the I/O and the control for the servos and stuff. We are going to pull out this big board, which is called the HTC TU board for the M Plus control. And we're going to take this board out. This is still valuable for somebody who's got a Mazak that's out there in the world. So I'm going to go ahead and pull that out, and then we'll pull this other board here out, and then we will figure out how to put our oak into the cabinet. Look at that thing. That is quite a board. Pretty cool. Lots of little connections and things. But we have no use for this anymore, as we are going to replace it with Centroid. So, taking this out, and we're gonna update and put a new, better system in. Look at that. That's so much wiring. Overwhelming. The NC board and the relay board have both been taken out, and we are ready to put in a new oak board controller. So you can add a ton of I/O to this board. You've got 4 places for axes, which we'll be using all 4 of those because obviously we have 4 axes to run. I think I'm gonna put this over in this area because this is where most of the I/O was coming. I'm gonna mount oak in there, and then we will begin doing the wiring of the motors and the drives. All right. We have the oak board mounted in here. We have our new DMM servo drives. All right, well, we are back, and I'm happy to report that the retrofit on the HTC 400 is finally wrapped up. I have one more thing to do, that's do the pallet changer, but everything else is ready to go. We have the tool changer, the tool carousel in here is all ready to go. The cabinets wired, the oak, everything for the probe. We have the drives in, the spindle drive, everything's wired and working. It's cutting accurately. So I'm gonna give you a little tour today, show you around. I've only had it like fully up and running functional for about a week, so I'm pretty excited about it. Took me a lot longer than I thought it would. I had some issues. We will get to those in a minute. All right, so this thing was actually a beast to wire. We are running 1 Delta drive and 4 DMM drives. We have oak here. We have a C2000 inverter. The biggest couple issues I had, the first thing that was a huge time suck for me was the 4th axis has a clamp on it that I didn't realize. So I kept getting a 4th axis position error. Every time I would go to move the 4th axis, it would kick out because it wasn't moving and it wasn't getting a feedback loop. And when I figured that out, then we had 4-axis motion. The next huge time sucker I had was the optic direct board. I've never worked with the optic direct board, and figuring out how it wires into oak and then how to wire it to a DMM, because Centroid only shows you the Delta or the Yaskawa wiring schematic, so we pretty much had to figure out and work with DMM and Centroid on how to wire up this servo drive. The final and major issue that I had on this retrofit was I bought the 15 horsepower spindle drive, and Delta says it's a 15 horsepower, but it's actually only a 10. So I had to end up buying a 20, which is actually only a 15. So there's been some time and money put in above and beyond just throwing the drives in and calibrating and cutting. But it's running pretty good now. I'm pretty pumped on it. Let's watch the machine move. Here's a peek inside. I've got this tombstone on right now. It's got a bunch of double vices, a single vice here. Working on getting the automatic tool probe or the tool length detector working. But we do have the chip screw working. That's fun. That's a luxury I've never enjoyed before. So chip screw is super solid. All right, let's make some chips. about a horizontal is, instead of having to bend down to look at the table, your line of sight is pretty much right on where the tool and the spindle are at. And I've grown pretty fond of it, honestly. It's nice to be able to see what's happening, and then obviously the chips don't pull up. So everything just kind of washes down into the bottom of the mill, and there's chip conveyors down in there. This has a Niagara coolant. It's way overkill for a job like this, but if you were trying to wash down a bunch of material, it gets after it. So, yeah, it's kind of fun. All right, well, I hope you enjoyed kind of seeing the workflow of the Centroid, both on the horizontal and on the vertical. One of the craziest things is I keep getting Y and Z mixed up on the mills because Y moves up and down and Z moves in and out, but it moves vertically and Z on the vertical mill. So just little things that you have to get used to, but you're using the same jog wheel, so your brain kind of has to adjust. But these are pretty cool little parts, nice to have done, and got a little run of 12 of them here. Hope you enjoyed it. Get out and play some golf or make something cool, and I will see you next time. Take care.